Hello, and welcome to Tech to Tech presented by Kaizen, where we will explore common cleaning questions and answers. This session has been pre-recorded and will include additional FAQs related to this specific topic at the end of the presentation. We hope it is 15 minutes well spent. Let's get started. I would like to introduce Kaizen's own Jason Schwartz.
Thanks, William. And thank you guys for taking the time to talk with me about citric acid cleaning today. We're going to talk about the role of citric acid in parts cleaning. And I like to start in kind of the everyday. So many of you probably have seen either infomercials for something like Goo Gone, or if you've gone to Home Depot, you've seen the Zep citric acid cleaners, or sorry, citrus cleaners, or something like Lemmy Shine, some type of just normal kitchen degreaser. And what's really interesting about that is that these are actually not citric acid cleaners. They're terpene cleaners. So the difference between terpenes and citric acid is terpenes are good oil cleaners because they're nonpolar hydrocarbons. In chemistry, we like to say like dissolves like. So if you look at the three pictures over here, on the top, you've got terpenes. In the middle, you've got mineral oil. And on the bottom, you've got citric acid. And it doesn't take a chemistry degree to determine that, one of these is not like the other. You see all these giant O's and OH groups on citric acid. Well, that means it's not quite the same as oil or terpenes. In fact, citric acid is polar, water soluble, and generally the opposite of oil. It's also a really good chelator. That means it's removing metal ions from solution. So these properties make citric acid well suited to clean oxides. However, it makes citric acid pretty poorly suited to degrease things. So one of the things that I always struggle with is when I talk to people in the parts cleaning world, they want to degrease parts with citric acid, and that's not the best application for it. However, citric acid is a great descaler. Uh, if you've got a kettle at home and you make tea or coffee, uh, a lot of nasty scale can be built up on that. There's a lot of cool YouTube videos of stuff that I like to watch on how to do homemade hacks. One of them is, dumping lemon juice into your kettle and descaling it. There's some good pictures here on how nicely it can clean it up. We translate that into the industrial side. Citric acid's going to do the same thing for your parts washer, right? It's going to unclog your nozzles. It's going to remove soap scum. It's going to remove excess RP buildup in both the washer and the dryer if you're using it. And so when you do a regular PM, one thing that we always recommend customers do is kind of flush the system out with citric acid. It's going to clean up your machine and it's going to get it, back to that almost new state. And because it's citric acid, it's a lot more environmentally friendly than other alternatives, right? It is an acid, but it's not a very heavy, strong acid like phosphoric acid or nitric acid, which are sometimes used to descale these machines. So it's going to be a much better, greener alternative. The other thing that citric acid is great at is removing rust. We talked about it being well suited as an oxide remover. Rust is essentially iron oxide. And if you look at the pictures here on the right, you've got some really mild surface rust. And one of the cool things about citric acid is even at a low to medium concentration and low temperatures, with just a little bit of mechanical agitation, it's going to clean that up really fast. The only thing you have to worry about is you got to make sure you rinse those parts really well because it's still an acid. And as all of us mostly know, uh, acid will catalyze the rust reaction. The last thing you want to do is clean up your surface rust and then have it happen all over again. So as long as you're rinsing, citric acid is a great rework tool to clean up surface rust. Unfortunately, not everybody can deal with just surface rust. In this picture, we've got the same type of part, but they've come out of diesel engine and long haul trucks, and they've got some really nasty corrosion on them. They've got some really heavy set, deep rust, especially on the top. So, what do you do in this situation? At first glance, citric acid isn't going to work. If you try to dunk these just into citric acid, medium concentration, low temperature, you're going to be really disappointed with the results. But we have to think a little bit. Why is that? Well, that's because you've already got too much oil and grease on the parts. And like we said earlier, citric acid just isn't a great degreaser. So instead, if you do in a first step of an alkaline reman cleaner to get all that oil and grease off, especially with some ultrasonic immersion, and then you go into a higher temperature citric acid bath, you're actually going to remove all of that rust. Now, you're still not going to be super happy because the part's going to come out looking like the picture on the right and it's completely coated in black. However, that is just the citric acid working to kind of coat the part in a black oxide instead of that ferrous iron oxide. So that black oxide, if you go into a second wash stage, can be pretty easily washed off with that same chemical from the first step, just your standard alkaline reman cleaner. And so you've gone from taking a really heavily rusted part and you've given it this nice even finish and taken off all of the rust using just your regular alkaline cleaner for oil and grease and citric acid. Along those same lines, because we know citric acid does such a great job on iron oxide with which is rust, it's going to do a lot with stainless steel passivation. So stainless steel is mainly iron, carbon, and chromium. The chromium is what gives it the stainless part of it. It's this chromium oxide layer that's going to form on top of the stainless steel and prevent it from rusting. And we know that it usually takes about 12 to 17% chromium in order to do a good passivation. One thing that citric acid can do is whether you are machining that stainless steel and you're breaking that chromium oxide layer, or you just want to enhance it, it can take off the free iron on the surface. And so by doing that, you either repair the chromium oxide layer that's been broken, or you're increasing the relative concentration of chromium on that surface layer. So by taking off some iron on the surface, you might go from 12 to 17% chromium and you'll get a much better passivated surface. And that's where something like the copper sulfate test, which you can see on the right, where you dip a little bit of copper sulfate solution onto a stainless steel part. If there's free iron left on the surface of that part, is going to show up like that top picture where it says fail. That's pink brown copper deposits are going to bind to the surface iron and show you a fail. Whereas once you've passivated something with stainless steel, you've removed that free iron and you're going to pass the copper sulfate test. And again, citric acid is a much friendlier alternative to nitric acid, which has been the standard for passivation for many years. Again, sticking with our well suited to cleaning oxide theme, it's also a great cleaner for copper corrosion. Copper corrosion is just another form of oxide removal. And if anybody's seen either copper corrosion or people have even made artwork like the picture on the right out of different copper oxides, it's not like rust. You get all these different colors: red, blue, green, even black sometimes. But that's just because copper oxides and copper oxidation work a little bit differently. In rust, there's one dominant reaction that is the rust reaction. It uh, dominates the rest of the different oxides that can form with iron. In copper, that's not the case. You have three, four different oxides that all can occur at the same time. However, because they're all oxides, citric acid can clean all of them. It's the same mechanism as removing surface rust from steel. So if you look at these pictures on the right, the one to the far left and the nasty solder joint up top are the same before picture. You look at the solder joint, you've got that green copper oxide that's dominating right around the joint. But all in all, the whole part to the left on the before looks really dark. And that's because you've got those different oxide reactions that are competing simultaneously. But when you look at the after pictures, not only when you use citric acid to clean this up, does it get rid of all of the green oxidation around the solder joint, but it also brightens up the entirety of the part because it's not just removing the green oxides, it's removing all the oxides. So it gives this added benefit of brightening copper. And again, same concept when you look at a metal like brass, which is 66% copper and 34% zinc. The same darkening concept applies. Same mechanism to clean and brighten your brass, citric acid. Whether you're reloading brass at home because ammunition is getting incredibly expensive, or you're an OEM producer of brass, you can brighten that up to a nice shiny finish using citric acid. So those are some of the ways that citric acid really helps your manufacturing process and fits into parts cleaning. Now, some of the frequently asked questions that I get about citric acid are, can you control citric acid with conductivity? Uh, no, it's not a good idea to control citric acid with conductivity for one main reason. You're going to get a great chart, and on a fresh bath, I'm going to be able to tell you exactly how much citric acid you have. However, the moment you start adding those oxides into solution, they're actually going to dissolve into solution, and they're going to affect the conductivity. So the soil loading is what spoils conductivity when you're using a citric acid bath. Those oxides are going to affect conductivity, and it's not going to become a very good method to monitor your concentration. Now you can do two alternatives, pH and titration, which are kind of the same thing. pH doesn't have great resolution. The difference between a 3 and a 3.5 on your pH scale can be the difference between 3 and 25% as far as citric acid concentration goes. So that's one of the difficulties with pH. Titration, it's got really good resolution. It's a bit tedious, but it's the generally preferred way to monitor citric acid. There's also some interesting work being done with sonic velocity, but that's kind of a topic for another day. So the next question that I always get, going back to our original slide, is, can citric acid clean oils? The short answer for that is no. But if you work with a specialty chemical supplier, you can go ahead and they can formulate a more niche product in order to clean some light soils. However, you're not going to get a lot of good oil loading or soil loading with the oils. What you're going to get is a very short bath life. Same thing with water soluble coolants. People ask me all the time, can you clean water soluble coolants? It's going to do a better job because it is a polar molecule. So you're going to get like dissolves like. You're going to do a little bit better with the water soluble coolants, but you're going to run into those same soil loading problems and you're going to have a shorter bath life. Both of these questions really are customers or people I work with that are trying to cheat in it and get to this last question, which is, can I clean and brighten my parts in one step? And again, the short answer to this is yes, you can do that, but you're going to have that same problem with oils and coolants that we were talking about earlier. The citric acid is going to be able to do that, but your bath life is going to be so short that you're either going to be changing it out every day, which would be great for me as the chemical supply guy. That's not going to hurt my feelings, but you're not going to like that cost in the long run. If you have a multi-step process, it actually gives you two really important advantages. One, you can control both the chemicals in different stages of your wash bath much, much better when you're trying to remove one soil in each step. And you're going to be able to get much more consistent results from day to day as well as longer bath life. So I hope you enjoyed it. That's the entirety of our presentation on citric acid. William, I'm going to turn it back over to you.
Thanks, Jason. Thank you all for watching this Tech to Tech session. If you'd like to discuss this topic further or have any questions not answered in the session, please contact your local Kaizen regional manager or send an email to tech@kaizen.com, and we will have someone follow up with you as soon as possible. Do you want to have exclusive access to future content sent directly to your inbox, or do you know someone who would benefit from these sessions? If the answer is yes, just go to the Tech to Tech by Kaizen.com, fill out the subscription form. If you like this video, be sure to follow us on our social media platforms for more expert cleaning content.